Hello everyone. Okay, we have a do now here. Fill in the reasons for the following proof. BD is a perpendicular bisector of AC. So that tells us is this guy right here is perpendicular to this guy right here. So what that means is, well, this perpendicular part tells us that there are right angles. There are right angles here and here. Let's call this angle 1 and angle 2. So we have angle 1 and angle 2 are right angles, and angle 1 is going to be congruent to angle 2 because all right angles are congruent. Now let's look at this part, the bisector part. That tells us that BD, like scissors, cuts AC into two congruent pieces. So that means that this guy is going to be congruent to this guy, or AD is going to be congruent to DC. So now we have two pairs of corresponding congruent parts. We need a third. We have to look at the picture to see if we can get anything from there. And you notice that BD is congruent to itself. Both triangles have that. So we can say BD is going to be congruent to itself. Okay, so we kind of got an idea of how to do this. And it looks like the way this proof is done is it's going to be by side angle side congruence. So let's get started. So when we have here, looking at it, right, what are the reasons? BD is a perpendicular bisector of AC. That's given. And using this information, we're able to get this. Why? Well, angle BDC, that's our angle 2, and angle BDA, that's our angle 1, are right angles. Well, why? The reason, perpendicular lines form right angles. Now, well, this is our angle 2 again, and they're saying that they're congruent to angle 1. Why? Well, all right angles are congruent. We usually do this in one step. Now the next part still uses the idea that BD is a perpendicular bisector of AC, but this time we're using the bisector part. So we have AD is congruent to DC. Well, a perpendicular bisector, the whole part bisector there, says that it divides a segment into two congruent parts. Okay, now we have this reflexive property here, and then as we did it, we realized that BD is shared by both triangles. So we're going to say BD is congruent to BD. BD is congruent to itself. Now, earlier, we realized that this angle right here is going to be an included angle, and we have sides here and a side here. So these triangles are going to be congruent by side angle side congruence. So that's important. Now, something interesting is since both triangles are congruent, that means all corresponding angles and sides are also congruent. What that really means is, well, with 3 pieces of information, we figured out 3 other pieces. So let's list what we already know. We know that angle BDC is congruent to angle BDA. AD is congruent to DC. BD is congruent to itself. This information told us triangles ABD are congruent to CBD, which tells us by definition that if two triangles or two figures are congruent, all corresponding parts are congruent. Well, in a triangle, there's 6 pieces of information, so we need to find what the other 3 are. If we go back at the picture, right, since the triangles are congruent, well, it looks like this guy corresponds to this guy. AB corresponds to BC, and the triangles are congruent, so they're corresponding parts. We have, again, what was it? It was AB. AB is congruent to CB. So we got one side, and we got to get information about two other angles. The two other angles we don't have information about through the proof was, well, this guy is going to be congruent to this guy. Okay, ABD, CBD. So the other piece of information we have is angle ABD is congruent to angle CBD. Lastly, we have another angle down here. These two angles are going to be congruent because they correspond. We can call them angle A and angle C. So we have angle A is congruent to angle C. And the reason we do this is because of the triangles being congruent, we have these other pieces are congruent. And the way we justify it is by saying corresponding parts of congruent triangles are congruent. We could shorten that up a bit.